This is an update to a video I did some years ago called Challenging Standard Cosmology, the Sun. And I was shown a tool that is a little more accurate and detailed than one that I used in that video. And it's called a sun position calculator. There'll be a link in the description. It starts out, I know it's too small to see, but I have to zoom out so I can see the sliders here and the chart. It starts out at default in Sydney, Australia. What they do on this chart is show you azimuth and altitude. Azimuth is where it is on a compass. If you're looking down at a compass, this is 0 or 360. You start going around to the right and you come to 90 degrees, 180, 270, 360 again. So if you think of it as looking down at a compass, and the compass in this case is a chart or graph. It's not telling you anything about Earth shape or anything like that. It's just a graph telling you the degrees. So if you were in the northern hemisphere and you are, as is to say more accurately, north of the equator, and you face south, if you hold out your left hand will be pointing due east, 90 degrees. So if you moved your hand back or rotated your whole self back, you would go at 80, 70, etc. So wherever you face, if you're facing due north, it's at 0 or 360. And if you turn to the right, you'll go by 10 degrees, increasing until you get all the way back again. That's just which way you're looking, basically, using north as the 0 or 360 point. That's all that is. That's what azimuth is. Now, these numbers are altitudes, or elevations of the sun. It starts out with 0, which would be the horizon. 10 degrees is just slightly above the horizon, and so on until you reach 90. It never goes past 90. 90 is directly overhead. So these concentric circles are elevations. These numbers around the edge are angles that you're facing away from north. Okay? Now, this little dot, if you can see it, is where the sun is at noon on January, or whatever day. I think it starts out at January. Let me put it back to there. And so noon on January 1st in Australia, in Sydney. I could expand this up a little bit because you can see that where I'm changing those numbers. So here's the sun. The sun on that day rises at 120 degrees, so you would have to be facing, if you face east and turn about 30 more degrees, you'll see the sunrise. And then the sun, as it goes across the sky, you'll see that eventually it gets to 130 degrees, then 140 and 50. That's the angle you're turning to keep watching the sun. Okay, so you're rotating, watching the sun. You started out at 120, and you keep rotating, and by noon, which is 180, solar local noon, regardless of what the clock says, this is where the sun is at its highest. It's zenith. Okay, that's what zenith is the highest above a particular location. And in this case, we're saying what's the highest the sun will appear to be above the horizon at a different given place in a given day. So on this day, which again, if we look up here, is January 1st and high noon, the sun has moved from 120 degrees to 180. So it's moved 60 degrees, and it's going to move another 60 by the time of sunset, which is 240 degrees. And it takes this kind of downward arc. Everything south of the equator will have this downward arc, or we could compare it as a frown versus a smile. A smile would be going, so the circles above this center line at the 90 to 70 mark, the east-west line, the circles above that are frowns. They're going down. I said that backwards before. These are the smiles. Okay, so that might come in handy later, but for right now, it's doing the slight smile. Okay, January 1st in Sydney, Australia, the noon takes this path from 120 to 240, and its highest point, we have to do the concentric circles to get to elevation. So if we go, the outside is 0, which is horizon, we go in 10, 20, 35 degrees. So the sun doesn't get higher than 35 degrees on January 1st. Okay, so now if I go back and change this, and I'm going to shrink the screen a little so you can see me do that. And the line is kind of faint, and later on I'm going to do some still shots where I color-coded the lines because I'm going to do different locations so we can compare them. But watch as I change the day. Okay, by the time we get to the equinox, doesn't matter whether it's spring or fall, equinox is when the sun, no matter where you are, the sun is going to be rising at 90 degrees and setting at 270. So it's telling us that the sun at the equinox, and that's why it's called equinox, is it's equal amounts of day and night basically, but it's on the equator. In the seasons, it will go 23.5 degrees north or 3.5 degrees south. And the reason the tropics are called the tropics is because that's the band on Earth where the sun can ever be 90 degrees overhead. So when it's south of the equator, going toward the Tropic of Capricorn, then the sun is closer to anything below obviously below the equator. So anything south of Ecuador and South America and parts of Africa, that band around that 23.5 degrees, I think that's a negative. And that's when the sun will be highest for those people. Okay, and conversely, in the north of the equator, when the sun is above the equator, and the June solstice, the summer solstice, is when the sun is its highest point of 90 degrees overhead, which is the Tropic of Cancer. It never goes farther than that. So physically, using the term as much as we can for where we can actually measure the angle from the ground to the sun, it's only ever 90 degrees in that band. So Sydney, Australia is not in the tropics. Therefore, the sun will never be on the equator. It will always be a little bit below it. But watch what happens. I mean, it's already rising and setting here, but there's a big difference between where it rises and sets and where it goes during the day. We can see we still got this smile going on, right? But now the sun is in the Tropic of Cancer. We're going to go to June 21st or thereabouts. It's hard to get precise on here sometimes. So the sun is still south of the equator, the east-west line, but it started out way up here at 60 degrees, and then it's 300 when it sets. So the rising and setting points we'll see no matter where you are on Earth are going to stay the same. They'll vary. That's 23.5, 23.5, so 47 degrees basically difference between where the sun sets and rises and sets. But where it is at noon, at that location, is never going to be way up exactly at the equator. So if we continue watching this, it'll go back down because the sun is going back toward the Tropic of Capricorn. Okay, so that's Sydney, Australia. And then what we can do is find a number of points on Earth. What I wanted to do was compare the farthest northern city, the farthest southern city, the equator, and 2 points halfway between. So when it comes to the north, you can't just enter North Pole. At least that didn't work for me. It wants a city name, someplace where people can live, although it will give you Antarctica, but there's obviously no real cities there. But we're going to try this place I can't pronounce in Svalbard, Norway. and see what kind of lines we get then. Okay, and it'll show you it on the map. Let's go back to January 1st. We'll keep it at noon. Just doesn't matter, what time, because that's just where it's going to put the little sun dot. Well, gosh, you can't see it because the sun is in at January 1st. It's just off the chart right now. But if I move this, see, it's gone. It's below the horizon, so it's a perpetual night there on January 1st. This is very far north, right? So the sun is just too far south to see. Now at about March the 1st, it starts to appear in the outer ring, which means it's barely above the horizon. And let's see how far north it goes. Okay, it gets up to about here, the summer solstice. So in summer, in Norway, I know it's counterintuitive. You think you should be seeing it up here, but again, we're looking at a compass, and we're looking at degrees around the compass and elevation in the concentric circles. So if you're in Norway, very far north, looking at the sun is actually going all the way around this circle because it's closer to the North Pole. Okay? So when you get to the summer solstice, it's the closest the sun is going to get if you're in this place in Norway. And we can see that there's no real rise and set point. It's just a circle. Okay, so it didn't rise and set. It's just always there. And if we play with this time of day, you can see the sun just go around that circle, right? It just goes around that circle. So it's not rising and setting. Let me try to get this back to noon. Whoop, I had it. Anyway, right about there. So, in the summer, when the sun is in the Tropic of Cancer, the sun doesn't rise or set. It just goes in a circle. Okay? Now, let's go back and we'll keep going through the years. Now the sun is going back south again. And at the fall equinox, a little bit farther. So when the sun is over the equator, it only appears to be about 10 degrees above the horizon in Norway. And then, of course, you keep going, and by this time in October, you don't see the sun at all until you see it again in March, early March. Now let's do the other extreme, Antarctica. So we're going to paste that in here. And it's going to be just the opposite, season-wise, from Norway, because we're at the opposite end of civilization, so-called. So let me move this up just a little bit. And we're going to keep the time noon. And, if we start at January 1st, you get supposedly in Antarctica. The thing is that we don't know that this is actually the case. Nobody but officially sanctioned government people can go there, even close to the actual pole. And any tours are very controlled. Was a channel called Taboo Conspiracy that said, sorry, we're closed regarding Antarctica and the Antarctic Treaty. But I don't want to pursue that right now. What I'm saying is this is hypothetical. I can't guarantee you that this is what you actually see in Antarctica, is the point I want to make. But as you would expect, it's the mirror image of Norway, where you see the sun only at the opposite seasons. So as we go through the year, it's getting warmer and warmer in the north. So the sun is going north away from Antarctica, so that by April 12th, you can't see it anymore, and it's going to be night until we get to about early September. And even then, it gets, depending on where they are picking this point in Antarctica, it only gets about 30 degrees above the horizon. Now, let's do the equator. We can do Quito, Ecuador. So you wouldn't expect, if you're thinking about this, a lot of change. Now, we know that the sun moves between the tropics, right? So on January 1st is here. I really shouldn't, should go by solstices, which the winter solstice, would be December 21st or thereabout. That's close enough. So by the equinox, there you are, the straight line going across. And then we go up to, whoops, I grabbed the wrong thing here. And then we go up to the summer solstice in June. But you'll notice it's always kind of straight. So if you're on the equator or thereabouts, if you're right on the equator, this is what you're going to see. So it's a straight line at the equinoxes. It's a smile when it goes north of the equator, when it goes to the Tropic of Cancer, and it's a frown when it goes to the Tropic of Capricorn. So you can see here by looking at Ecuador that it's the equator is a dividing line between, like I said, the smiles and frowns. And so if the sun is staying south of that, it's frown. And by that I mean the way the arc tilts. So, and then north, obviously the opposite. So now let's try two places halfway between. So 45 degrees north will be a place called St. Albans, Maine. And let's let's start out in January like we've done with all the others. If you're in Maine, you're looking south towards the equator. And on January 1st, the sun rises at about 120, 240. Again, we'll get back to that. We'll show them all at the same time so you can see that the sunrise and sunset are at the same points depending on the time of year, no matter where you are. It's the arc between that's different. So, since we're in a northern hemisphere, we got the smile going on because the sun is taking this arc, it's going up, down, up, or north, south, north. And as you get toward the equinox, which would be right about here, the sun is rising and setting at 90 and 270. But the sun at that point in Maine, let me bring this up a little bit. You can see the altitude is 10, 20, 30, 40 degrees at the equinox. At the solstice, near the end of June, it gets up to about a little under, this is 80, 70, so not quite 70 degrees, so it's about 68 degrees or so during the summer solstice. But look at that arc. I mean, obviously we know it's rising and setting all at the same point as 6,300, but it takes a sharper turn, so it's moving faster elevation-wise. And then, of course, as you go through the year, the frown gets the smile gets a little less extreme. It starts to straighten out. And by the end of December, the winter solstice, the sun has only come up about 20 degrees above the horizon. And you would get the same in a place called Sacramento, Argentina. So let's check that out. That's the mirror image of this place in Maine. And you can see that we've got the big frown going on here now. So let's go back to January 1st. And you can see what happens to that. There's the equinox when it rises and sets at 90 to 70. And at the solstice, this is south of the equator, right? At the solstice, a little bit farther yet, it's gone, at the June solstice, it's only about 20 degrees over the horizon. Okay, so what does all that mean? It's hard to, I just want to emphasize how the angle of the sun changes on a day at a location, and the fact that they all rise and set at the same points doesn't mean they all take the same path across the sky, which means what angles things are at. Okay, so the angle on the compass is consistent for all places on Earth as to the time of year, which varies between the tropics. So you go so many degrees above and so many degrees below the equator, those are the tropic lines. So that band of from about 60 to 120 is, all the difference you're going to see. And so now what I want to do is go and show this slideshow instead. So what I did is I color-coded the lines, made them darker so you could see. It doesn't matter where the little dot of the sun is. I just, traced over the lines. And this is what the equinox looks like. Okay, so we've got all of our locations here. And for some reason, I'm not seeing my cursor. Let me do that. There we go. So here's the 90-270. Here's the line you saw for Argentina. That's the halfway point below the equator, south of the equator. And then far south of the equator is Antarctica. So it's a more extreme arc. And the mirror image, of course, in Maine, USA, which is about the 45-degree latitude. It's going to take this arc, and that place in Norway is more extreme on that end. So this is what it looks a lot like the icon or logo of a certain television station in the U.S., if you recognize that, the all-seeing eye, basically. But that's what the extremes and the halfway points compared to the equator look like on the equinox. So if I'm north, I'm going to be seeing these lines. Okay, I'm looking south, and I see this, everybody at the equinox, we're seeing the sun. There's a little variation, but the sun is basically going 90-270. That's why it's an equinox. And so this is what you would see looking from the north looking south. If you're in Maine, you're going to see at the equinox, whether March or September, you're going to see the sun get 10, 20, 30, 40 some degrees overhead. Whereas if you're all the way up in Norway, you will only see it 10 degrees overhead. And the mirror images if you're in the south looking north toward the equator. And then we also have, this is what one of the extremes look like, the summer solstice. Makes different shapes because obviously a lot of things have changed. You can't see Antarctica at all, right? Because it's gone off the chart in mid-April. But we do see that here's our northern perpetual sun. Here is the halfway point doing this big frown. And here's Ecuador doing the very slight smile. Okay? So then, obviously, the other extreme, the December solstice, just everything flips mirror image. So now instead of seeing Norway, that's off the chart in mid-October, we see, if this is true about Antarctica, I can't emphasize that enough, nobody can verify with a trustworthy non-government source that this is actually what they see. But we see that, if you're in Ecuador, you see the slight frown because it's in the tropic. You're looking a little south as you watch the sun rise and set at the same times everywhere on Earth, but it takes a different arc, which this arc means, of course, that our elevation is changing, but also the azimuth, because here it was about 115. Now, at this point, it's 120, then it goes to 140, 50, 60, until it gets to 180. So that's why it makes this arc is coming from that data. So if you're standing here at noon and you're in Ecuador and you're looking south at the sun because it's in the Tropic of Capricorn, at 180 at solar noon, the elevation will be about 75 degrees. So if we count from 90, 80, 70, 65 degrees. So you can do the same with any of these other arcs. And the point is, let me go back to equinox. The point is that when you read these charts, you have to be careful of what you're looking at, but it does tell you some interesting things. The first thing, of course, that depending on which tropic the sun is in, you're going to go everywhere from sunrise at 60-ish degrees to sunrise at 120-ish degrees. Okay, depending on where you are. And then in the middle, of course, it's at 90 degrees, but it never goes beyond the 60 and 120 for sunrise. And of course, it's going to be the equal opposite on the other side of the compass on each of those times. But the elevations depend on how far away you are from the equator. But as we saw, even in Ecuador, when it's summer in the north, the sun is still pretty high, but it's at a little under 70 degrees. So what does that tell us about anything? It's just telling us how to read these charts mainly. That's the mostly what I wanted to do today, although I, again, have to emphasize that Antarctica is an unknown. You can project what it would do because other things do mirror images, but that is assuming something about the Earth that we can't assume. Science doesn't assume. So until we have trustworthy sources in Antarctica who can actually see whether there's a perpetual sun half the year, we don't know that that's the case. Okay, so it would be more accurate to look at just the northern things, the things we can test, which the one in Argentina, in this province in Argentina, is halfway there, and it does a mirror image, but again, we don't project when we want to know what the sun's actually doing. And what the sun's actually doing in Antarctica would answer a lot of questions, because we need to verify this, not just assume it because of a pattern we see in other things. Because we don't know if there is, in fact, a 6 months on or off sun in Antarctica. Because if Earth is a flat circle, then this can't happen. Right? Because the sun would, if you rotate it on a spot, like you pick a spot, if you're in Ecuador, and you just keep facing the sun all year, every day, you can rotate on your spot and always see the sun. All right, during the day. Okay, but if you're at the North Pole, okay, you're going to see, close to the North Pole, you'll see it. Sorry about the cuckoo clock. I wasn't anticipating recording during that, but I suppose, yeah, trying to figure things out sometimes is a little cuckoo. But the point is that during the northern solstice, the summer solstice, we're pretty sure that this happens in Antarctica. Okay, you can see, we've known people who've been at least really far north who would say we see something like this, the sun doesn't set. Okay, but we can't know that for sure about Antarctica, and that would answer the questions, and that's why you can't go there, most likely. Because if you tried to stay in one place and watch the sun in Antarctica, you only see it for 6 months. It won't rise and set after that. But we don't know that yet. Anyway, you can draw your own conclusions as to what this chart shows, but it is just a chart or a graph. It's not telling you anything except the angle along the ground, along the compass, that the sun will rise and set at, and where it is at any given point between, it will tell you the angle. And like I said, if, for example, you pick this time of day, this where the sun is here, for example, in Argentina, so you're in the southern hemisphere looking north, south of the equator looking toward it. After a few hours, about mid-morning, you're at, the sun is due east, even though it rose at 120, it's now only at 90. So it took from 120 to 90, and as it elevated. So here's the elevation going 10, 20, 30, 40, 50 degrees or so. And the azimuth also changed. So you can see more illustrations of the changing altitude and azimuth in the original video, Challenging Standard Cosmology of the Sun. But I just wanted to emphasize this particular chart and how we can see the sun arcs a little bit differently using this chart. So I hope this is helpful, and please leave some comments under the video if you have any thing to say about whether I misread the chart or anything like that. Thanks for watching.